Hey guys, Buildzoid here, and we're back with the 5700X3D because in the previous video I said the CPU doesn't have access to Curve Optimizer, and that was wrong. So it doesn't have access to Curve Optimizer in the BIOS, but as it turns out, 5800X3D owners have been Curve Optimizing their CPUs using this utility over here that I didn't know exists. So yeah, we're gonna see how this goes. I don't have very high expectations. I've tried using Curve Optimizer on a 5950X and the various 7000 series CPUs that I have, and it basically does nothing. like from a performance perspective, it's basically useless. As in, it produces performance uplifts in the at best 4% range, which is functionally nothing as far as I'm concerned. Especially considering how much instability it can cause, but who knows, maybe the 5700X3D will be very different, which I really doubt because the chip already basically runs at 4.1 gigahertz as is, so I don't really see how slightly reducing the voltage is going to do much of anything. But yeah, we'll see, I guess, right? So we're not actually really going to be worried about the frequency. We're going to be worried about the score. So actually, I think I might just close. No, CPU-Z shouldn't really affect Cinebench too much. It's not like hardware info, where hardware info will quite happily lop off like 50 or 100 points, depending on how slow your CPU is and how much monitoring stuff you have, well, monitoring. So, yeah, and so out of the box on a 240mm AIO, admittedly the ambient air temperature is like 19 degrees. It's winter in the UK, and my flat isn't exactly very insulating. But yeah, so we're at like 4 gigahertz-ish right now. So I don't have high hopes. If the curve optimizer somehow manages to get the CPU to run at 4.1 or like 4.15 gigahertz constant, we should see at least a 5% performance uplift, but something tells me that's not going to happen. But, you know, we'll see. Also, yes, this video is basically a filler episode as far as I'm concerned. So if it seems like the quality is even worse than usual, that's why. Who knows? Maybe I'll learn something. So 5321, cool. So yeah, this really isn't affecting the I mean, I haven't done anything, so this isn't negatively affecting the performance whatsoever. Wait, am I gonna have to manually set all of them at the... We're gonna start at wait, why is that still highlighted? Okay, we're gonna start with -10. I'm assuming this is how this works. I already don't like this UI. Did that do anything? I don't know. I guess we'll see. And I don't think that did it. Well, it is running 4.04 instead of like 4.016. I guess the voltage might be slightly lower. It's still reading at 1.25. Like, really, ideally, we wouldn't... Well, with Ryzen CPUs, the core voltage reading is actually like what the VRM is seeing, so that's probably accurate. I guess we'll have to check with hardware info later. Like, to be fair, I think even the, like, static BCLK overclock that I did with this CPU did functionally nothing, right? That was, like, 5,600 points instead of 5,300 points, and it's like, eh. Especially considering how much effort that took and how much stuff broke because of it. So 5354. So previously we had a 53, like, 21 or something. So yeah, that's like... That's not even 1%. 1% would be a 53 extra points. So that would have been like a 5370 or something. Let's try -20, I guess. Actually, wait, I have an idea. I can just highlight. Okay, well, doing this through a capture card, it's not too bad. We can just do it this way. Oh. I wish there was just like an apply to all button. Okay, let's see if that does anything. And the answer is not really. Well, at least it hasn't caused any performance regressions. The core voltage admittedly is lower, but the frequency hasn't changed, so... Yeah, and this is why I've never been a fan of curve optimizer. It's just like it doesn't actually make the CPU run faster. It just lowers the voltage, which is like, what's the point in doing that? Um, it's not like your desk. I'm assuming your desktop doesn't run on battery, so it's like that did literally nothing. That is exactly the same score as we had at -10. Okay, let's see if like things start breaking if we go to like -30 or something. Um, Though I assume -30 is gonna just we're gonna see an even lower core voltage in CPU Z, and the score still isn't gonna change. Which to me, like you could just run the CPU at stock. Like I don't see the point in like fit like this is it's like the voltage slider on a modern Nvidia GPUs. It's like yeah you can play with the voltage slider. It doesn't actually do anything. So I don't know why like it may as well not be an option. Um, so yeah, we're getting even lower core voltage in CPU-Z, but I bet you the performance is still going to be exactly the same. Because this is like my whole issue with Curve Optimizer. It's not telling the CPU to boost more. Like I want more boost. I don't want lower voltage. I just want more gigahertz. And this is not more gigahertz. This is the same gigahertz at lower power draw, which is like if it was a laptop, then maybe that would make sense. Because you'd like extend your battery life. I don't know why you'd be running Cinebench on your laptop, but who knows? Maybe you need to like render in the middle of nowhere. Um, and the performance didn't change. I know technically it's like 5 points lower, but that's margin of error. Like that's not like it's the performance is regressing or something. It didn't change. So is there? Can we punch in arbitrary values? Like, could I punch in say 38? Wait, that's not a 38. There, 38. Apparently, yes. Well, that's fun. Not that I think it's like I'm wondering is like at what point is it going to make the CPU crash at this point? Because the thing is like AMD is shipping these things with a ton of extra stock voltage, but like I would much rather have the extra stock voltage and then just have a way to force the CPU to clock higher rather than like eliminating the safety margin. Or, well, because it actually both are eliminating the safety margin if you think about it, right? If you run higher clocks at the same voltage, you're eliminating the safety margin by running at higher clocks. But if you're lowering the voltage and running at the same clocks, then you're still eliminating the safety margin just without any performance gain. And it's just like, well, I would much rather, more gigahertz at the same voltage rather than the same gigahertz at less voltage. Just saying. Um, so yeah, this is pointless. It's not like the CPU is particularly challenging to cool, though I guess if you were trying to run it on a Wraith Prism, which it doesn't come with a heatsink, so Um, you know, like admittedly I haven't tested like a single like a basic single tower cooler, mostly because I don't have any on hand. Um, but the Wraith Prism wasn't exactly struggling with the CPU until I tried to run Linpack on it. And yeah, so performance still isn't changing. Um, you know what? Let's just go to like -48 now. Like, because I'm assuming at some point it has to like it has to crash, right? Like something has to happen. And our core voltage, wait, the core voltage isn't even getting lower at this point. Yeah, it's just not doing anything at this point. Okay. Which I guess makes sense because like AMD's typical curve optimizer range was only down to like -30. Um, so I guess at some point the like boost algorithm just kind of ignores whatever you punch in. So I guess we'll put it back up to -30 and then play with some of the other options because there's obviously the limits tab. Um, but overall, like I'd say the 5700, like looking at this, the 5700X3D is like you just do nothing. I'd say it's a do nothing CPU. Like yeah, the stock voltage is and I think we might actually be starting to see a performance regression at this point. But like the stock voltage is admittedly insanely high for a CPU that only runs at like 4 gigahertz. But at the same time, unless you have like cooling issues, it doesn't really have any negative side effects. Um, so yeah, I don't know why you would like go and like try to do anything about it, basically. All right, because the thing is like that's like like CPUs having insanely like relatively high stock voltage relative to the clocks that they run at. That's standard practice, um, right? Like because the CPUs they ship with a safety margin. What surprises me about the 5700X3D's stock voltage is that it's such a massive safety margin. Like 1.25 on stock is like for 4 gigahertz is like I would have expected it to ship at like maybe 1.2. And so when I ran it and saw 1.25, I was like, well, that's weirdly high for a 4 gigahertz CPU. Um, so yeah. So okay, so we're back to our 5351. Um, does that actually work? Yeah, that didn't do anything. We're still at 4.04. But I guess we could try run single core and see what happens. Yeah, so single core runs at like yeah, so that apparently didn't achieve anything, which I didn't expect it to because yeah, okay, so that doesn't do anything. Good to know. Um, what else can we do? Well, we have the various limits, but I'm assuming if we just set the fifth scalar to 10, it's just not going to do anything again. And the answer to that question is, yeah, that actually just doesn't do anything. We might be seeing slightly higher voltage or something, but I don't think it'll change performance. This is one thing that's like generally been frustrating me about a lot of modern CPUs is how like the CPU manufacturers keep giving you all these like extra overclocking utilities and it just doesn't. It's just like back in the day when you had a Sandy Bridge CPU, right? The CPU came at a stock clock of like 3-ish gigahertz, and you could overclock it to like 4.5 to 5 gigahertz. So the performance actually went up when you overclocked it. And then now you have like modern CPUs where Intel has all of their like thermal velocity boost and like what is it? The like adaptive voltage and all that wackiness and And it's just so your 6 gigahertz CPU can run sometimes at 6.2 instead of sometimes at 6. Um, which basically means your performance didn't change because going from 6 to 6.2 does basically nothing. Um, kind of like how going from 4 gigahertz to 4.1 gigahertz does basically nothing, or from 4 to 4.2 also kind of doesn't do a whole lot of anything because that's like 5%. It's not even 5%. No, it's 5%. Yeah, that's 5%. Um, anyway, so the scaler doesn't really seem to do anything, which is to be expected. Because like the main issue with the CPU is just like the clock limit is really low. So, you know. So like yeah, you can fiddle with the like voltage behavior and the power consumption, but like there's no way to force the CPU to run faster. Um, it's not power limited, it's not thermally limited, it's clock limited. Um, which, you know, like it's not advertised as being an overclockable CPU, so I guess that's just not too surprising, but um, well, that's kind of that. I guess we can try mess with the various limits as well. I'm kind of wondering, like, how low do we have to set the PPT before the score starts to drop? Um, actually, and we'll do that with the stock core voltage, because the thing is, like, I don't think we're power limited even on full voltage with the CPU. Because it's a 8-core Ryzen at 4 gigahertz. I'm thinking, like, even on a 100-watt power limit, it'll probably be spitting out about 5,300 points. Because at 4 gigahertz, like the power consumption of a CPU is a function of both the like core clock and the core voltage and the operating temperature. Um, but the core clock on this thing is so low that I really and Cinebench is not a particularly high power consumption test. So maybe if I ran something else like say LinPack, we would be seeing bigger differences from the curve optimizer. But the 5700X3D is a gaming CPU, right? Um, if like if you're stress testing it because you've set up some overclock or something, I would say LinPack is a good idea. But if you're just like if you're actually just using it for gaming, then like you're not really that concerned about the fact that like 100% load of the CPU power throttles a bit. So anyway, let's start with like 120. Um, we might see a somewhat lower score already. I guess AMD's insanely high stock voltage does have like minor consequences. Like, I'm wondering how much we need to drop the power limit before we see the score drop to like, I don't know, under 5,000 points. I wouldn't recommend power limiting the CPU. This is just like, I'm just kind of interested to see how it behaves. Wait, it scored better. Wait, isn't this like almost the same score we were getting with the curve optimizer? um, oh, well, that's fun. Honestly, I thought it would be worse because the like core frequency looked kind of like it looked somewhat lower than and then the score came out the same. So shows you like that. That's the whole reason I don't really like pay that much attention to frequency readouts on modern CPUs because it's just like it's not reflective of the performance a lot of the time. Um, I guess the thought process at AMD with like setting the power limit so insanely high is that the CPU is just going to smash into the thermal limit or the frequency limit before it ever reaches the power limit, so they don't care what the power limit is or something like that. Because like I'm really struggling to think of a scenario where that 140 watt power limit actually makes sense. Especially on an X3D, which is like, these are really meant to be gaming CPUs. Because there's not really any like intense workloads that you'd really want to be running on an X3D. Um, so at 100 watts, it's still like maybe we're starting to see some performance regression. Let's try 88 watts. That's what, 12 below? No, that's not. Let's go like 85, 15 watts. Because I've been going in. Wait, no, if I wanted to do the same step of like 22 watts, then it would have been like 80. Or like 78. Let's try 15. It's still running at like apparently the same frequency. So basically, like messing with the TDC or EDC for especially day-to-day usage is like I don't think that's gonna do anything. Um, because we're on an 85 watt power limit and the CPU's not like it might be hitting it at this point. I'm kind of hoping that it's hitting it, but like 85 watts at like 1.25 volts, the CPU has to be pulling like 60 amps or something. It's pulling nothing basically. Um, 60? No, 60 is too low. It's like 70 amps or something. Hey, okay, we might be starting to see hints of a performance regression. Okay, let's just go to 66. It's okay, finally, we're below 4 gigahertz, barely. I bet it's still going to be like 5,000 points. It's probably actually it might very well be well over 5,000 points. It's it's just crazy how much like well, I guess, it's like, well, the frequency is locked, so like, it doesn't matter if the power limits and the voltages are insanely high. It's like people can't overclock the CPU anyway, not without bending over backwards, and like losing PCIe and stuff. So why not ship it with a 140 watt power limit that it's never going to reach? It's still doing 5,300 points. Okay, let's go like 45 watts. Like now it's gotta slow down, right? Now again, I should point out, Cinebench R20 really isn't a very thirsty workload on Ryzen. Like if I was running LinPack, it would be pulling more power. But the thing is, LinPack is kind of exceptionally heavy in my experience. Like that's why I use that for stress testing and Cinebench for like gauging CPU performance, very roughly. Um, okay, so now we're seeing some serious frequency regressions. So that's interesting because that's like, so there's like nothing, 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 and then you go from 66 to 45 watts and the CPU suddenly drops like half a gigahertz. No, I guess we could try set the curve optimizer now and see if the CPU goes back up to running 5,300-ish points at 45 watts with minus 30. Yeah, so that's a big performance drop. Okay, so what about 55? Nah, I want to see 45 watt power limit with minus 30 curve optimizer. Um, Because with minus 30, right, on the stock power limit, the CPU was running at around 1.1-ish volts, and we're still not getting anywhere near 4 gigahertz. Okay, so now we're gonna bring the power limit back up, because I'm kind of wondering, like, and I don't, like, I'm not, like, it doesn't make sense to me to do this if you're building a system with this CPU, because again, we're not gaining performance here. We're just, like, fiddling with the power consumption, and under normal, like, if you're using the CPU to play games, it's not going to be at 100% load. So, um, the, like, power savings that you're going to get are going to be even smaller. $49.87. Oh, that's a, decent improvement. Okay, let's go back up to 50. Well, let's go up to 55 watts, see what happens. Oh, and now it's back to running at 4 gigahertz. Yeah, so that's really interesting because on the stock like voltage curve, it could run at like 66 watts. So there's not much of a difference. Or like yeah, like it's not that much. Well, I guess 55 to 66 is like a 20% increase in power consumption. So I say not that much of a difference because like going from 55 to 66 watts, like it's 11 watts. That's like nothing. But in terms of percentages, 20% is actually pretty substantial. Um, right, 20% on like say for like if your 4090 pulled to 20% more power, it would be pulling instead of 450 watts, it would be pulling like 600 almost, something like that. So now we're back up to 5350. Neat. Um, I was kind of wondering if there's any difference if we set it to 66. This is so frustrating, like seeing the CPU just refuse to go over 4 gigahertz. Like there's like or like 4.04 because like I know there's headroom, right? Like I ran this chip at 4.2, and then there's just like yeah, and there's no way to get the CPU to do that without like breaking PCIe and stuff. Um, which is just so disappointing. I wish, like, imagine if AMD brought back like the black. Well, technically all of the like non-X3D CPUs are fully unlocked, so it wouldn't really make sense. But in the Phenom 2 days, like you had the black editions or something, which were like the unlocked multiplier models. But now it's just like everything except the X3Ds is unlocked, so it wouldn't really make sense to make that again. Oh, 5364. So a very maybe it's actually slightly faster now. I'm kind of wondering if okay, so the other thing that I kind of want to try is because this used to be an issue with older AGSAs was that if you set the PPT really, really high, the CPU would like power throttle for some reason. Um, so we're going to keep that at 140. Wait, was it PPT? No, it was the EDC that was the problem. So we're going to set okay, we're just going to set everything sky high and see if anything happens. Like I think it might slow down. Is what I'm thinking will happen. Or it'll just do nothing, so maybe they fixed that. Because that used to be a thing with, like, the 5950X is if you set the EDC really high, like 300 or something, the CPU wouldn't hit it, but you'd already, like, you'd get less performance than if you set the EDC to, like, 200. Which I'm pretty sure is a bug. Because, like, Threadrippers come with, like, really, really high EDCs, and they don't do that. Right? Because like the Threadrippers have a stock power limit of like over 200 watts. So the stock EDC is already way higher than what a 5950X would ever use. Yeah, so this CPU doesn't seem to do that. So maybe it's fixed, or maybe the CPU just isn't big enough to run into those issues. 5364 again. Okay, let's see if like we just set it to in like basically well, I mean 255. Like the stock power limit is basically unlimited. Um, but like, what if it was more unlimited? And the answer is nothing. Nothing happens. Okay, that's cool. So maybe that's fixed. It's been a while since I've run the 5950X, so yeah. I really want to try this CPU with a motherboard that has an actual external clock gen. Not because I think it'll like fix the boost algorithm getting disabled or something, but because I want to be able to go over 120 megahertz on the BCLK or 119, because the standard frequency range for BCLK on AM4 is up to 119 megahertz. You get that on every motherboard. Even and admittedly on a lot of motherboards it causes massive issues once you go past like 103, but you do have the ability to set the frequency sky high. Okay, so that really didn't do anything. Like, yeah, it's like slightly lower than the 5360 whatever, but that I'd count as margin of error for the CPU. So yeah, so curve optimizer on the CPU, pretty pointless. Really doesn't do much of anything. Just to make absolutely certain, I'm just going to turn it back off again. Cool utility, though. Not sure I would ever actually use it for, like, my own personal... Actually, no, I know for a fact that I wouldn't use it on my own personal system. But I guess if you really want to mess with your CPU for no other reason than that you want to mess with your CPU, then this does make it a lot more convenient than setting stuff in the BIOS. The next thing I do want to mess around with is obviously memory overclocking on the CPU. Because the thing is, like I say, oh, I want to run it on an X470 motherboard, but the X470 motherboard and, well, I have two X370 motherboards that I could potentially try it with, and I have a X470 motherboard that I bought in, like, not 100% working condition, and I haven't really bothered to figure out what's wrong with it yet, because I bought it at, like, when like, because like busy with AM5 stuff, so I didn't really want to go through the process of like digging out a CPU to verify what's wrong, like figure out what's wrong with the board, and yeah. Anyway, so yeah, if you run it with no curve optimizer, it just spits out like 20 points less. So I guess like in a way, if you just want to build a very lazy system with the 5700 X3D, you can buy a 5700 X3D, stick it in a motherboard, and do nothing. Like that seems to be, or at least do nothing to the CPU. I don't know. Maybe it'll benefit from memory overclocking in certain scenarios. This is the first 5000 series X3D chip I have. And actually, I think this is the OS that I have Steam on. Do I? Is this the one that I put Steam on, or... Wait, let me check something. Oh, I do have Steam. Yeah, so I might actually do a game benchmark. A game benchmark, not multiple game benchmarks, because there's a game that I play that brings CPUs to their knees. It's single player. You've probably, well, actually, no, if you watch my channel, you might have heard of it, but, yeah, it absolutely, like, it can take a 14900K into the 50 FPS range. It takes my 7800X3D down into the 50 FPS range, which is the whole reason I decided to also test the 14900K, was to see if, like, hey, would it run significantly better on a 14900K? And the answer is not really. But yeah, so I'm kind of wondering, like, how would a 5700X 3D interact with that game with and without a memory overclock? Um, but yeah, so I'll probably test that and nothing else, and I'm not sure if I'll even include the results in a video. Depends if the results are interesting, I guess. As in, like, the results are something other than performance didn't change. But anyway, yeah, so that's it for testing out Curve Optimizer on the 5700X 3D. It just doesn't do anything. Um, I don't know, like, yeah, like, it's not much more to say than that. So hopefully you found this somewhat interesting, if not particularly useful. And that's it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comments section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store, where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to all of that down in the description. Well, there's links to all of that down in the description. It would be much appreciated if you check them out. And that's it. So thanks for watching, and goodbye.